In this lesson, we are going to look at the area of trapezoids, kites, and rhombuses, or rhombi. I'll be able to find the area of special quadrilaterals, the trapezoid, the kite, and the rhombus, and apply properties of right triangles to find missing measures. So we have Pythagorean theorem, we have trig, and we have the properties of special right triangles that we may have to use in some of these problems. And even though we might not do an example of all of these, please be aware that when you're working on the practice, all of these cases could come up where you would have to find a missing dimension before you could solve the problem. So let's look at our special quadrilaterals and kind of look at that quadrilateral flowchart that we looked at the beginning of the year. So quadrilaterals, the only property of a quadrilateral is they have 4 sides. And then we kind of start to go into this flowchart and family. So we talked about parallelograms, and parallelograms have opposite sides that are congruent and parallel. We talked about special parallelograms, your rectangle and your rhombus, and we are going to talk about the rhombus today. So one of the quadrilaterals that we're going to talk about is over here in the parallelogram family. And then we are also going to talk about trapezoids and kites. So trapezoids and kites are in their own separate family. Isosceles trapezoids have legs that are congruent, just like isosceles triangles. And then kites, we're going to talk about those properties in the next video. Let's look at trapezoids first. Okay. So the area of a trapezoid is 1/2 the sum of the product of the height and the sum of the bases. Okay, so 1/2 the product of the height and the sum of the bases. So that's the way it's written right here. Okay, this is the official one. I actually like to write it. I think we know by now that I don't like to write things as multiplied by 1/2. I would rather write it as the height times the sum of the bases divided by 2. I think it's just easier for us to deal with division by 2 rather than multiplying by 1/2. So let's look at where those values come from. So you have 2 bases, so base 1 and base 2. They are the bases that are parallel to each other. So these bases are parallel, okay? So that's how you know that they're the bases and not the legs. This would be a leg, this would be a leg, and then our height, just like in a triangle, is the perpendicular distance, and in this case, it's the perpendicular distance between the bases, okay? So we have to see that 90 degrees right there. So even if this trapezoid was turned on its side, that height would still be the distance between the bases. So I think you should write that down because this idea is going to become really important for us in the next couple chapters, okay? So the height is that perpendicular distance between the bases. So let's look at our first example. Find the area of this trapezoid. So you'll see here that I turned this trapezoid on its side so we could talk about that height. So here are my bases. It doesn't matter which one's base 1 and which one's base 2, okay? So base 1, base 2, or vice versa. And then that height is that perpendicular distance. And we know that it's the perpendicular distance because we have that 90-degree angle, okay? So that perpendicular is that 90-degree angle. So we know that that is its height. So if we write out the formula, area is equal to the height multiplied by the sum of the bases divided by 2. So let's fill it in with what we know. We know our height is 5, and we know our bases are 4 plus 6, all divided by 2. And then we're just using order of operations to combine to solve this problem, to evaluate that expression. So the area of this trapezoid is 25, and because it's an area, I'm using yards squared. So there's my area of this trapezoid. So here's the next trapezoid that we're going to find the area of. So you'll see here that we have one base. Okay, so we can call that base 1. But we're missing base 2. But we do have enough information to find that. So I should have put it in the picture, but I'm going to put in that this right here is a 90-degree angle. So if that's a 90-degree angle, then we know that this right here is the height of the figure. So kind of breaking this up into things that you know, or to move things around. But if we move this height over to here and draw it in right there, then we know that that's 4. And then we have a right triangle here. And if we can find this value right here, then we can subtract it from the 9, which is the total. So the 9, which is the total, and we can break that up into y, and let's call that x. And then if we can find the x using the right triangle, then that y is our base 2 because it is opposite and parallel to that figure. Okay, so I'm going to pull out that triangle. Our height is 4, our slant is 5, so I can use Pythagorean theorem to find this figure. So when you use Pythagorean theorem, again, this lesson is not about Pythagorean theorem, so if you need a refresher on that, go back to that lesson. I know that this is going to be a 3, 4, 5 triangle. That's a Pythagorean triple that I know off the top of my head. So if you know that, you don't have to do the Pythagorean theorem. But if you do, stop the video, make sure you can do the Pythagorean theorem, and that you get that value b is 3. So since that is 3, okay, so this length right here is 3. And the total is 9, then this length right here must be 6, okay? So now I kind of have a new trapezoid, and I will draw it. That we know the height is 4. We know that's a right angle, bad right angle, that this is 9, and we just solve for the other base, which is 6. So now we can use our formula for the area of a triangle. So area equals the height multiplied by the sum of the bases, b1 plus b2 all over 2. So area equals the height, which is 4. The bases, we knew one of them, which was 9. We solve, oops, that should be a plus sign, not a comma. It's not a coordinate point. Plus the other base, which is 6, which we solve for using the Pythagorean theorem and then segment addition postulate, all divided by 2. So pause the video and see if you can calculate the area of this trapezoid. So when I did my calculations, I got that the area is 30 and my units are feet, so that is feet squared. So the area of this trapezoid is 30 feet squared. Now, we use Pythagorean theorem in this problem to find a missing measure. Just be aware that you might have to use trig. Like if you're given this angle right here, you could use trig. If it's a special angle, 45 or 30, 60, 90s, you could use the properties of special right triangles to solve the problem as well. So all of those things are still in our basket that we're able to use. So that's how you find the area of trapezoids.